This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 10 of graphing trig functions. We're continuing to graph sine functions, and in this video we're going to do y equals the sine of x minus pi over 2 plus 3. Alright, so first of all we notice that in the parentheses we've got x minus pi over 2, so that has to do with the phase shift, and if we set that equal to 0, we have x equals pi over 2. Now remember why we're doing this. We're trying to figure out what we could plug in for x so we could just compute the sine of 0. And so since x equals pi over 2, think of that as plus pi over 2, this is the shift on the x-axis, which we call the phase shift. So the phase shift, which is the same thing as the horizontal shift, is pi over 2 units to, well, if it's positive, it means to the right. All right, what about this plus 3 over here? This means if we've got the graph of the sine, we've got y equals the sine of all this stuff. If we graphed it, then we're going to add 3. So all the y values are going to be shifted up 3. So the vertical shift is 3 units, and it's positive, so we're going up. Alright, so over here on the left, we've got our information for y equals sine of x, which we always want to remember. Period of 2 pi, amplitude of 1, the range is -1 to 1, and we've got these 5 key points, as usual. Now we want to graph y equals the sine of x minus pi over 2 plus 3. The period is still 2 pi, and the amplitude is still 1. Remember, the graph of just the sine of x, y equals sine of x, period's 2 pi. And the amplitude, that has to do with the coefficient in front of the sine. All right? But we have a vertical shift from this plus 3 of up 3 units, which means we're going to add 3 to all the y coordinates of the sine function over here, to these ordered pairs here. And the phase shift, we figured out, was pi over 2 units to the right. Remember, we add, because it was a plus pi over 2, when you took this, what was in parentheses, and set it equal to 0. So we added pi over 2 to the x coordinates. So I've started this off for you. So to find the new x coordinates for this function, we want to add pi over 2 to all these x coordinates here. All right, so 0 plus pi over 2 is just pi over 2. Pi over 2 plus pi over 2, well, that's 2 pi over 2, or pi. I'm going to leave it as 2 pi over 2, because if you have a common denominator, it's going to be easier to graph these ordered pairs. All right, then we have pi plus pi over 2. Well, you could get a common denominator here, right, by multiplying pi by 2 over 2, and then that gives you in the numerator 2 pi plus pi, which is 3 pi over 2. And you can continue doing this all the way down, but if you recall, remember, once you see the difference between one x coordinate to the next, it just is the same all the way through. Notice I started off with 1 pi over 2, 2 pi over 2, 3 pi over 2. Next one should be 4 pi over 2. Last one should be 5 pi over 2. So you can see the pattern, or you can go over here and add, right? You'd have to get a common denominator again for this last one to see why it's 5 pi over 2. So for our key points, these will be the x coordinates of the key points. And now let's do the y coordinates. How do we get the new y coordinates? We add 3. All right, so to get the sine of x minus pi over 2 plus 3, right? That's my y coordinate. I'm taking each of my y coordinates over here and I'm adding 3. Now, I think we could do that in our head. In other words, we're just going to add 3 to both of these, to all of these, right? Notice the sine function are in black, but if I add 3, I'm just going to write this answer over here. So that would be 3. So this gives me the ordered pair pi over 2, 3. The next one will be 4, right? 1 plus 3. 0 plus 3 is 3 again. Negative 1 plus 3 is 2. And 0 plus 3 is 3. And remember in the sine function, whatever the first number is, every other number is exactly the same. So these are the order pairs that we want to show on our graph. Those will be our key points. And I know we can simplify these x-coordinates to, like the second one you can call pi, the fourth one you could call 2 pi, but it's actually easier when you draw a little chart to just go ahead and leave them all with a common denominator. All right, so here is our original function, y equals the sine of x minus pi over 2 plus 3. And here are our 5 key ordered pairs that we want to graph. So for the x, notice it goes from pi over 2 to 5 pi over 2. All the denominators are 2, so I may as well make every 2 spaces pi, right? What about the y values? The lowest point is 2, the highest point is 4. So this entire graph is above the x-axis. So I'm going to draw the x-axis lower. Okay. And I need to go to at least 5 pi over 2, so I need at least 5 spaces to the, right, if correct, if I have each space be a pi over 2. So how about if I just go ahead and do it right here. All right, let's mark it. So there's 1 pi over 2, 2 pi over 2. I'm just going to call that pi. 3 pi over 2, 4 pi over 2. That would be 2 pi. And of course you could put all of these coordinates down. It just gets very crowded on your graph. Here's going to be negative pi. Let's see, I go over just a little bit more to the left. And negative 2 pi. What you really want to do is practice trying to get these segments, right, these little line segments, all about the same length. You really want it to make it look as accurate as possible. All right, on the y-axis, let's see, we go from 2 to 4, so we have to get up to at least 4, right? So 1, 2, 3, 4, let's call that 5. You want to always label at least one number on the y-coordinate and at least one number on the x-coordinate. I'm sorry, not on the x-coordinate, on the x-axis. So at least 1 point. So let's do these now. We have pi over 2, 3. All right, so here's pi over 2 and up 3. There's our first order pair. And then we've got 2 pi over 2, 4. So that's the same as pi, right, which is right here. But you just count. There's 2 pi over 2, and you go up to 4. Then we've got 3 pi over 2 down to 3 again. Just what we would think happens with the sine function. And then we've got 2 pi or 4 pi over 2 down to 2. And then up here, and hopefully you see the pattern emerging. The next one should be up here, etc. And if we went to the left, we would be going down from here, and then up, and down, right? Until you get it. Now, remember, this is not a mountain. No. It's a nice smooth curve, so we have to sketch it carefully. So you sort of have to make it curve, and then it changes direction until you get a picture so it's clear you understand what's going on. It's going to go down, and here we go. You just do a little arrows at the end to show. And so there we have y equals the sine of x minus pi over 2 plus 3. Now what's happened, it's as if you shifted the entire sine curve over pi over 2 spaces. So instead of 0, 0 here, what happened? This ordered pair, 0, 0 on y equals sine of x, it shifted pi over 2 to the right and up 3 spaces, and there's your new point. So if you wanted to see the graph of y equals sine x in green, for instance, some people just graph that function, and right, so Here's just a little bit of it. And then they just take each ordered pair and they move it. They say, I'm going to take this 0, 0, go over pi over 2 to the right and up 3, and they'll get this new point. They'll take this ordered pair up here at pi over 2, 1, and go pi over 2 to the right and up 3. So that's another way some people like to do it. Okay? This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.